Hi children, welcome back. Last class we have seen that chemical properties of metals. In that we have seen chemical reactions of metals with water as well as with acids. Now today we are going to see when metals react with other metal salts. You know that reactivity series, isn't it? It is the arrangement of metals in the decreasing order of their reactivity. So, that reactivity series we know metals are the top, highly reactive metals are there at the top of the reactivity series, and the middle we can see moderately reactive metals, and at the bottom of the reactivity series we can see least reactive metals. Okay. So, when we discuss that metal reaction with metals reaction with other metal salts, there we have to consider the reactivity series. In case of a metal is reacting with another, another metal salt, for example, if we consider their iron is a metal, isn't it? You know. So, when iron is treated with a copper sulphate solution, another salt solution, copper sulphate, as you know, it is a blue colored crystal. So, copper sulphate solution, we can dissolve that blue colored copper crystals in water, so that a blue colored solution will be absorbed there, and that we call copper sulphate solution. So, when iron is for example, iron nail we can take. When an iron nail is dropping in copper sulphate solution, there occurs a displacement reaction. What do you mean by displacement reaction? There we can see. When iron is reacting with the copper sulphate solution, this iron will displaces copper there from its solution, and iron sulphate FeSO4, after displacing copper from its position, iron sulphate and copper will be produced. This is known as displacement reaction. In that displacement reaction, a highly reactive metal will displace a less reactive metal from its salt solution. In the case of copper and iron, we know the position of these metals in the reactivity series. If we are recollecting the reactivity series, potassium, sodium, calcium, magnesium, aluminium, isn't it? Zinc, then comes iron, and after that lead will be there, then copper will be there, like this arrangement of metals in the reactivity series. So, when we observe this reactivity series, iron is above copper. So, iron is more reactive than copper. So, when a more reactive metal displaces a less reactive metal from its salt solution, then the reaction is known as displacement reaction. Once again, a more reactive metal displaces a less reactive metal from its salt solution, and the reaction is known as displacement reaction. This is a single displacement reaction which we have studied there in the first chapter, isn't it? We are all familiar with that. And here the color changes also we have to mention. Sometimes you will get a question, what do you observe when an iron nail is dropping to copper sulphate solution? So, at that time we have to tell the observation there. When an iron nail is dropping into copper sulphate solution, iron is silvery grey color. Iron has silvery grey color, and copper sulphate is blue in color. The solution is blue, and during that reaction, iron displaces copper from copper sulphate, and iron sulphate will be produced, and the color of iron sulphate is light green color. So, blue color of the solution will change into light green color, and copper, the color is brown color, reddish brown color is observed for copper. Okay, so these are the observation for this displacement reaction. During the when a metal is treated with another metal salt solution, if the metal is highly reactive, then not only highly reactive, if it is more reactive than the metal present in the salt solution, at that time more reactive metal will displace a less reactive metal from its salt solution and corresponding products will be produced there, and that is known as displacement reaction. Okay. And for this whether the reaction will take place or not, that is predicted depending upon the position of the metal in the reactivity series. Suppose for example in this case, if it is opposite way, copper sulfate, instead of copper sulfate, iron sulfate is treated with copper, at that time will the reaction take place there? No. As you said, there is no reaction because iron is more reactive than copper and copper is less reactive than iron. So, the displacement is not possible for this. So, this is known as the displacement reaction. Okay. So, in the displacement reaction, we can see a more reactive metal will displaces a less reactive metal from its salt solution, and there will be sometimes observations. And sometimes gases will be evolved there. If, for example, if we are dropping the zinc to sulfuric acid, you know there is one non-metal which is present in the reactivity series, hydrogen. Hydrogen is the non-metal present. Here is the position of hydrogen and hydrogen is placed there, and it is the non-metal present in the reactivity series. So, zinc is above hydrogen, so zinc can displace hydrogen during this reaction, and at that time zinc sulfate and hydrogen gas will be evolved there, and hydrogen evolution will be observed as bubbles. We can observe bubbles are coming out of the solution there as hydrogen gas. And how do you check the presence of hydrogen gas there? By showing a burning matchstick there. If it produces a pop sound, definitely we can say the evolved gas is hydrogen, and this is also a reaction of metal with acid. So, definitely we can say that the evolved gas is hydrogen. So, this is the displacement reaction. Okay. Now, we can compare. The reactions of, before comparing we can see what are the chemical properties of non-metals also. Chemical properties of non-metals. Now, we can see one by one the chemical properties of non-metals. First one, we have seen in the case of metals, metal react with oxygen to produce metal oxides, isn't it? And same way non-metals also react with oxygen to produce non-metal oxides. For example, carbon. Carbon is a familiar non-metal for you, right? So, carbon reacts with oxygen to produce carbon dioxide. So, non-metals react with oxygen to produce non-metal oxides. And what is the nature of metal oxides produced when a metal is reacting with oxygen? Yes, as you said, it is metal oxides are basic in nature, isn't it? Same way, non-metals are produced reacts with oxygen to produce non-metal oxides, and these non-metal oxides are acidic in nature. When this non-metal oxide, carbon dioxide, is dissolving in water, we will get carbonic acid. So, as acid is produced there, definitely we can say that non-metal oxides are acidic in nature. So, metal combined with oxygen, metal oxide, non-metal combined with oxygen, non-metal oxides which are acidic in nature. Okay. Then second, reaction with water. In the case of non-metals, there is no reaction with water. Reaction with water. In the case of non-metals with water, no reaction. Do you remember that one non-metal is kept in water to avoid the reaction with oxygen? You have studied that in 8th standard. Do anyone remember? Yes, it is phosphorus. Phosphorus is a non-metal which is stored in water. So, we can easily say that for non-metals there is no reaction with water. Okay. Now, we can see non-metals reaction with the non-metals reaction with the bases, as metals react with acids. So, non-metal reaction with the bases, we can say non-metals reaction with the bases are a complex reaction. Complex reaction. When a non-metal is reacting with the bases, the reaction is a complex reaction. So, here we will discuss only this much. Non-metal reaction with the bases are complex. Okay. So, now we can see non-metals reaction with the acids. Non-metals reaction with the acids, there is no reaction. With acids there is no reaction. As the metals react with acid, metal, salt and hydrogen, but here non-metals do not react with acids. With water no reaction, with acids no reaction, but with the bases the reaction is complex. Okay. Then we can see displacement reaction. In the case of metals, there was displacement, there is displacement reaction. When a metal more reactive metal displaces a less reactive metal. Same way, if we consider non-metal, there is no displacement reaction at all. No displacement reaction. Okay. So, if we conclude the reactions of chemical properties of non-metals, non-metals react with the oxygen to produce non-metal oxides. Non-metal oxides are acidic in nature, and there is no reaction when with water, there is no reaction, and with acids also no reaction, and non-metals reaction with the bases are complex, and non-metals do not show any displacement reaction. Okay. And if we consider the reaction, here we have discussed the non-metals reaction with bases. Some metals also react with the bases. For example, zinc and aluminum, all these metals react with the bases to produce corresponding compounds, and hydrogen gas is also liberated. When these metals react with the bases, zinc and aluminum can react with the bases also, and it can produce hydrogen gas during that reaction. So, not all the metals, certain metals, some metals will react with the bases also. Bases also they will react, and hydrogen evolution is there, and corresponding complex salts also will be produced there. We have seen sodium zincate, sodium aluminate, like so sodium metal aluminate will be produced there, and we have already seen that sodium zincate formation, and that is in the case of metals with bases. Not all the metals, a few metals, some metals will react with the bases with the liberation of hydrogen gas. Okay. So, this much is about the chemical properties of non-metals. When we compare these chemical properties of metals and non-metals, metal oxides will be produced with oxygen. They are basic in nature, and case of non-metals, non-metal oxides acidic. Reaction with the water in the case of metal reacts to form oxides and hydrogen evolution, and there is no reaction for the non-metals with water, and with acid metals will react to form metal, salt and hydrogen gas. Non-metals there is no reaction with the acids. Some metals react with the bases and their product will be little complex and hydrogen evolution will be there, and metals, non-metals reaction with the bases are complex there, and metals show displacement reaction and non-metals do not show any displacement reaction. So, this much only about the comparison of metals and non-metals when we consider the chemical properties. Okay, that much only children. Thank you.